All right, so last year you learned in geometry about a circle, and you learned that a circle has 360 degrees going all the way around, right? So then you learned that if you go from the center of the circle and you make a radius going from the center out to the edge of the circle, and let's say we draw another radius out to the edge of the circle there, we have what's called a central angle. So this central angle right here, and let me just point to that for you so that you can see that. So if you see this central angle that's right here, remember that that central angle, whatever the degree measure is, this arc will also be that same degree measure. So if I had, let's say this angle here was 40 degrees, then I know that this arc is also 40 degrees, okay? Because the central angle is equal to the measure of the arc that it cuts off. Now we can also look from a different perspective, because sometimes we don't always want the measure of the arc in degree measures. We actually want, oh, that's a beautiful circle, isn't it now? We want the actual length of it. So let's take the same picture. So let's say I have something like this again. But instead of me wanting to know the actual angle measure, I want the actual length of this arc, like in feet or inches or whatever. So what I could do is think about that. I mean, I can't really take a ruler and, lay it along a curved piece, but what I could do is that I could take a piece of string or a piece of rope and lay it right along here, and then take the rope, stretch it out, and then I could put a ruler against that, and then I could find the length of the arc that way. We also have a formula that's going to help do that for us, so here we go. All right, so what I'd like you to do is if you would take out your packet and turn to page 5, and you'll see at the top of page 5 it talks about arc length and radian measure. So what you'll see up there is you'll see a circle, and you're going to see that it is giving you a formula. And it kind of gives you the same picture that I was giving you on the last slide here. Okay, and the formula is S equals R theta. So this is going to be the formula that's either going to help us find the length of an arc, the radius of a circle, or the central angle. And I'll discuss that a little bit. So if you look at this picture here, and look at that picture that's at the top of page 5 in your packet, okay, so the distance from A to B in that packet, if you look, is called S. That's the length of your arc. Again, like I said in the last slide, if I take a piece of string and I were to lay it along that curvy piece there and then straighten it out and I were to measure it with a ruler, that's the length of the arc. So perhaps maybe you want to write this underneath the formula. S stands for the length of the arc. Okay, now I can probably figure out what the R is. I'm sure you could also. The R is just the radius of the circle. Okay? All right, the last thing is this theta. Now theta, you can tell by the picture that you have there, is the central angle. Here's the only thing that you need to remember about theta. Okay, the central angle, here's the big thing. It has to be, and please make sure that you're writing this down in your packet, it has to be in radians. Now we've discussed that, radian measure versus degree measure. Okay, so if your angle is given to you in degree measure, you need to convert it to radian measure. If it's already in radian measure, then you're good to go. Okay, so what we're going to do is we're going to go to the packet and we're going to try a few of the examples, okay? So we're going to start with number 10. All right, so if we read number 10, it's talking about a wedge-shaped piece is cut from a circular pizza. Well, we all know about this, don't we? So basically what we have is we have like a slice of pizza here. Okay, I'm going to make it a big slice. I'm hungry. And the diameter of the pizza is 12 inches. Well, if the diameter of the pizza is 12 inches, then obviously the radius would be half of that. So the radius is 6. The rounded edge of the crust of the piece measures 4.2 inches. The rounded edge of the crust. Well, the rounded edge of the crust, if you think about that, okay, this is your rounded edge of the crust right here. So that would be your S, okay? So they're telling you that your S is 4.2 inches. So 4.2 goes right here. And then it says to the nearest tenth, the angle of the pointed end of the piece of pizza in radians is. So what they're looking for is your central angle right there. So what we're going to do is we're going to say S equals r theta. You should be writing this in your notes. Okay. Well, we know the length of the arc is 4.2. We know that the radius is 6. And we're looking for the angle measure. How easy is this? So we're looking for theta, so we have to get theta by itself. So we're going to divide both sides by 6. And then we're going to put that in our calculator. And we're going to get theta equals 0.7 radians. And there's our answer. Right? Told you this was easy. Okay, so now make sure you get that in your packet at number 10. And then when you're ready, flip to number 12. All right, so if we look at number 12, this one's just a tad bit different, nothing too crazy, but essential angle whose measure is 2 pi over 3 radians intercepts an arc with a length of 4 pi feet. And they want you to find the radius of the circle. So let's start with that formula, S equals r theta. Now let's see, they gave us the central angle. Let's double check, because like I said to you 2 slides ago, we need to be very careful that the central angle always has to be in radians. And in this case it is. So I'm going to just put 2 pi over 3. Okay, so that's the length, or that's the measure of the central angle. All right, now let's see, it intercepts an arc with a length of 4 pi feet. So that would be S. And then they want us to find the radius. So here we go. Okay. So again, what we're going to be doing is getting R by itself this time. Now, I could divide by 2 pi over 3. I think what I would prefer to do instead of that is, you know that if you divide by 2 pi over 3, that would be the same as multiplying by the reciprocal. So that's what I'm going to do. Okay, because what that will do is that will cancel out this, and I'm going to do the same thing over here. So I'm going to multiply by the reciprocal of the fraction. There we go. Okay, and the reason why I like to do that is I can see, oh, 2 pi and 4 pi, that's going to cross out. The pi's completely cross out, and 2 goes into 4 twice. See that? Okay, and then it's pretty easy from there, because then you can see that your radius is 6. Now let's just read. It says find the radius of the circle in feet. So that would be 6 feet equals the radius. Okay, and again, you should be taking notes in your packet when we do this. All right, so when you're done with that, let's go on to number 14, okay? All right, so let's look at number 14. This one says, what is the length of the arc on the unit circle subtended by an angle of 120 degrees? Ooh, fancy words. Subtended just means that it cuts off an angle of 120 degrees. Now, not that you need to draw a picture, but I'm just going to draw a picture so that you can see it. First of all, it's a unit circle. And remember, a unit circle on an XY axis, this is not the best picture in the world, means, and let me see if I can use a little pointer here. I think that might be a little bit better for you. Okay, which basically what it means is the distance from here all the way out to here is 1 unit, or the distance from the origin all the way up to the edge of the circle this way is 1 unit. Actually, from the origin in any direction would be 1 unit, which means, come on, let's make a conclusion here. That means that the radius is going to be 1, okay? All right, so then let's look at that then. So then I know in my unit circle that this distance right here is I'm going to just kind of try to make it a little thicker there, that my radius is 1, Okay, now it says that it cuts off an angle of 120 degrees. Remember when we're doing S equals R theta, do you remember that I said that the angle cannot be in degree measure? And this one is, so we're going to have to convert that. So it wants the length of the arc, so that's S. We know that the radius is 1, because it says unit circle, and a unit means 1. Now, here we go about that angle. So that angle is 120 degrees. If you remember, if you have an angle and you want to convert it to radians, we just multiply it by pi over 180. And I'll put this over 1. Okay, so I have 120 pi over 180, and that's in radians. Now, listen, it's totally up to you. You can reduce that if you want to. It's really not necessary because we're going to be throwing it into the calculator anyway. So I'm not going to bother because I'm lazy. And then we're going to just put this over 180. Okay, so the rest is in the calculator. Well, listen, we know obviously 1 times anything is just that anything. So really all you need to do now is take your calculator. Go ahead, take your calculator and hit 120. Multiply by the pi button, okay, hit enter, and divide by 180. Or you can do your little, math fraction, not your math fraction, your alpha y equals to get your fraction thingy. You know what I'm talking about. Anyway, so any way you slice it, you're going to end up with 2.0944, and they didn't give me units, so I'm just going to write units. Okay, and they didn't tell me what to round to, so I'm going to go out 4 places and round that 4th place. And there you go. Okay? All right, so what we're going to ask you guys to do now is we would like you to do the odd numbers in your packet. Okay? So you're going to go up to number 15 doing the odds. So that would be 9, 11, 13, and 15. Do those in your packet. Show work because we're going to be checking those. Okay? Thank you. Bye.